Good day, everyone, and welcome to the Advanced Track Hackathon kickoff stream. Today, we are going to do a huge presentation by our valued partners. We will start with Vectara. We will also today hear LlamaIndex, Together AI, and Structured EO, and Tonic AI. Also, I would like to share the presentation, that we are going to use for today's walkthrough. Can you just confirm that we have the presentation open? Mhm. Okay, so today I'm going to be your MC. I'm event manager at LlamaIndex. My name is Katya. So if you, just nice meeting everyone. I think that you already met me running few hackathons. So wanted to say if you have some questions, please let me know. But please use our chats for that. We have event going on for 7 days. And as of today, we have a bunch of speakers coming from the different partners. And we will post these people a little bit later. Before that, we'll just do the walkthrough. Also on Monday, as of April 15th, we will have a workshop hosted by a person from Vectara. They're going to be discussing tools for building user interface for AI. And moving on Tuesday, there would be exciting workshop hosted by Offer about the advanced rack. And next Friday, exactly a week from now, we're going to have the deadline, which is happening at 9 p.m. SAT, and PST time would be 12 p.m. exactly. Okay, let's move further to the LlamaIndex. A small introduction for those who are new to the kitchen and want to know more what we are doing here. So basically, LabLab is doing hackathons, online hackathons, hybrid hackathons for people who wants to incorporate AI in their creations, in their apps. And we are by all our means help builders, developers, startup enthusiasts to make it real by providing networking, innovation, technology, partners, and different opportunities to make these ideas actually pretty much physical, right? What you have in your mind to build it and to spread it around. I want to speak about Vectara. Vectara is our main partner for this hackathon, and their, of course, most important creation is basically rack system. So we will also hear more about the Vectara introduction from the Devrel, which is Offer. Yeah, he's going to speak more about their main projects in a bit. So I will pass the mic further to him. As for main condition for this hackathon, we need to have your Vectara account to be eligible to participate. So please make sure that you register on Vectara. Um, Also very cool if you would have a Vectara account, like email in Vectara account, the same as in the LabLab AI, so they match. And we will still approve people until 17th. So there's still a couple of days left for registration. So please spread a word around to your friends, colleagues, initiate everyone to participate and to build together. So as I mentioned before, Vectara is well known for their RAG system, and this hackathon is specializing in creating an app with the RAG chatbot, which is utilizing question answering application. You can use any industry you want. It could be app in legal, manufacturing, healthcare, retail, insurance, and more. The most important is to actually utilize the RAG technology in the building process. As usually, success criteria for for each app, there is the same success criteria. Firstly, like how you use the technology. Obviously, like you have to be responsive, right, to the hackathon challenge. You have to show how each technology incorporated properly. Then presentation. Pitching is the key of success here, because this is the time, this is your momentum, this is the time where you can gather someone's attention, and sometimes these people could be very useful, yeah, and you would gain this recognition. So please be sharp, be clear, and make sure that you tell everything about your project in the presentation, everything important. Obviously, business value. AI industry is blooming right now, and there are so many amazing projects, and sometimes, your eye can get a little bit like blurry. So please make sure that you're building something really valuable. It's bringing the value to the society, to the business world, to the economic world, and you see the actual usage, right, in the day-to-day life. But of course, you should also keep sharp and be original. Yeah, so please be unique in your idea. And yeah, just make sure that your idea is very well wrapped up in the implementation of the technology. So with that being said, we also have prepared a little bit of tutorials for you. This hackathon is also sponsored by Vectara's new chatbot functionality. Please check out tutorial about this chatbot functionality. It's super cool one, it's super long one, and you will find there a lot of useful information. I strongly recommend you to do that ASAP. Also, we linked the Vectara Hackathon guide on the event page, so please check it out. Um, Generally speaking, we basically prepared a lot of educational materials for you so that you feel comfortable with building. But of course, you can always ask on the chat, like any questions that you might have. So that shouldn't be a big deal for you. Moving on to the hackathon prizes. And this event is really special because we have so many special prizes. That's literally like crazy. I want to firstly pay attention to the main track. So there would be 3 places. Yeah, you are going to get the cash prize and also the equivalent in the Vectara credits. And as for special prizes, oh my God, so many nominations for best use of Vectara chatbot, best project with LlamaIndex, then best project using Together API, then best project using unstructured, best project using Tonic AI. So as you can see, there are a lot of nominations, a lot of opportunities to shine. Yeah, and as for these hackathon prizes, please read all the details about the distribution of the prizes, how you can be nominated in the main track and special prizes. There's notice shall be on the event page. This is our mentor leads that are going to be present for you during the hackathon. So this is in case if you will have any questions. And now moving on with the platform walkthrough. So I know that there are a lot of like, let's say like oldies, right? And I'm not sure if we need to do like very detailed platform walkthrough, but today still I have 5 minutes left. I will do a quick walkthrough. And this is basically how it's going to look for you. You need to, well, obviously, like have a team. You need to create a team or join one on LlamaIndex AI. You need to meet your team on Discord. You are either having the concept already or you're coming up with the new concept. Then you need to also communicate with mentors and get one. And then you're building your prototype, your MVP, and then you're submitting your solution by the end of hackathon. That's the whole process in a very short 6 steps. For that, please make sure that your profile is filled out so you have a lot of information that would help you for networking and for basically like being, you know, like accepted in the teams and knowing what are you capable of, right? And what are your skills and background and so on and so forth. Then you also like, yeah, this is the explanation how you either like create or joining the team. Um, this is just a basic information about the team. Yeah, like you will see that there are different names of the team and you can join. And basically, this is the place where you would also submit your project later on from your team account. Then I also told you about the Discord, yeah, that you have to be present. All the jam is happening on the Discord, and you will see the channel for this hackathon. Also very important to be in touch with mentors. So you can use I Need Help channel in LlamaLab on Discord, and there you are going to get this support. You can tag mentor also in Discord for any kind of guidance that you need in terms of technical or business issues. This is the representation of how this channel looks like. I need help, yeah. And to find an information about the hackathon itself, you will see that in the folder of active hackathons. And this is where everything will be happening, all the communication. So please stay tuned there as well. I already told you about the success criteria, and one of the very important things is your presentation. So when you make your presentation as a submission of your project, there are a few things to pay attention to. Firstly, product demo, presentation itself, project description, demo, and GitHub link. So basically, you will just have to fill in everything in your account. It will really help you to be evaluated. And once you're about to present, you will have to upload your presentation, like a video format. And of course, we have a strict deadline that video shouldn't be longer than 5 minutes. So please be sharp. And with that being said, again, like if you need any additional help, Discord, tag in mentor, being active on the chat in the active hackathons from LlamaLab AI, and there you'll find everything. And yeah, basically, I'm passing my mic to Offer. Offer is the head of developer relations from Vectara, and he is the person behind this hackathon, behind the creation of this hackathon. So, yep, I'm welcoming Offer, and basically, yeah, finishing my small introduction for this hackathon. Thank you, guys.
Thank you, Katya. Can you hear me okay?
Yeah.
All right, so let me also share my screen here. 1 second. I think this is it. All right, perfect. Well, hi, everyone. Thanks, Katya, for that introduction. And again, thank you for all of our collaborators and partners in this hackathon, in addition to LlamaLab AI. LlamaIndex and Tonic and Unstructured and Together AI. You'll hear from all of them later today, but I wanted to give you a little bit of introduction to Vectara and to this hackathon. And so let me start here. I think all the excitement that you've all seen around large language models is because, and this is our belief at Vectara, is that every application, whether it's a consumer application on your phone or it's an enterprise application, every piece of knowledge, everything we'll do is going to transform and have a GenAI interface, right? So this is a transformation at the size of, when we got the first, iPhone, right, where every application started changing. So we're at that point in time where this is starting to happen, and I think it's super exciting to be part of this revolution, and I welcome all of you as well to start building and learning about this space. And this hackathon is about RAG. RAG is probably the most common sort of architecture or flow for creating kind of using LLMs with your own data. And so RAG stands for Retrieval Augmented Generation. And the way it works at a very high level is, when you issue a query, when the user of your application issues a query, the LM does not respond right away. Instead, it waits to receive some facts. It's pieces of text usually that match the user's query and are relevant for that. So this retrieval process gives the LLM some facts that are relevant based on your data from your document that you indexed, and then it answers the question based on this data. So you sort of tell the LLM, hey, here's some facts, and here's the user query. Please respond not just based on what you were trained on as a model, but also based on these facts. And it turns out that helps a lot. First, we're just being able to customize the responses to your data, but also to reduce hallucinations quite a bit. And as Katya mentioned, there's a bunch of use cases around question answering. Chatbots is a very common use of this, and a bunch of others. And so again, so I mentioned, it's good to reduce hallucinations and LM with your own data, but let me talk about a few other reasons of why RAG is useful. And we'll see this in the demos in a little bit. But RAG outputs are explainable. So by providing citations, as you'll see in the demo later on, the user can see not just the response of the LM, but what facts and where did the LM get that user. And this is very good at increasing user trust because the users can then look at the response and look at the references and the citations and go explore more if they choose to. It's also private, so you don't have to train on your data. Your data doesn't leak into the LLM, as people like to say. Because you don't have to train, it's also more economical. You don't have to fine tune a lot of times, like every day or something, if the data changes. So it makes it a lot more easy to use in that sense. And one thing I like to mention is that also it enables a kind of more control around authorization and access control, especially in an enterprise setting where you can tag each piece of information with metadata to say this is only visible by, let's say, the HR department. So when the facts come back from the retrieval side, those will be only the facts that are filtered by the user, who the user is and what they can see. So it allows a lot of these really, really great characteristics for RAG. Now I talked about hallucinations. I'm pretty sure everybody at this point knows what it is, but just in case, I want to share my favorite example. When you ask ChatGPT, I think this is version 3.5, did Will Smith ever hit anyone? You see what the answer is, and the answer is like, no, we think Will Smith is just a really nice actor and didn't assault or hit anyone. But of course, we all know what really happened, which is in the Oscars, right, where he hit Chris Rock. So this is an example of a hallucination. And it usually happens, as you see in this case, because that piece of information was not available to that model. And this is why it's sometimes very useful to train on your own data. Of course, in an enterprise context, sometimes there's data that a trained model like ChatGPT or Gemini would never actually have access to because it's internal, confidential, or data that the company considers their internal information. All right. So I want to show you this slide. This is kind of a busy slide, but this is how you build a RAG pipeline if you do all the steps yourself. If you want to choose to do that, and I'll encourage you not to do that in the next slide, but if you choose to do that yourself, I wanted to show you how complicated it could be and where some of the roadblocks might be. So I'll start with this data ingest flow in the blue arrow, right? So here, usually the data sits somewhere, You have it on S3, you have it on the web, you have it in a database. It could be in some applications like Salesforce or Jira or something. And then usually there's a step of document processing, which includes extracting text. So if you have a PDF or some other binary format like a doc or a PPT file, you want to extract the actual text from that. And then you do what's called chunking, which is breaking long sequences of text into smaller chunks. Now, before I proceed, I just want to mention that I put some names of companies or vendors that sometimes do pieces of this process or all of it. And it's not necessarily a comprehensive list, it's just a few examples in each, right? But continuing on, we have the text and we create these chunks. And now what we have to do is we have to take every chunk of text and we have to embed it. And what this is it's called an embedding model. And you can take the text and convert it into what's called a vector representation. And this is usually a vector of numbers that somehow captures the semantic meaning of that piece of text. And then you store it in what's called a vector store. And again, there's a couple of examples here, but there's, to my last count, about 65 different vector databases available. It's very confusing which one you should use. And then you, of course, store the text chunk somewhere too. And that's really what happens during the ingest flow. Now, then a user issues a query from some application that you have. It's usually like a search bar or something. And the query goes into the embedding model as well, gets embedded. So you get this vector representing the meaning of the query. And then you sort of match them up and you want to pull, and this is what I showed earlier, you want to pull the most relevant facts from their index. So it could be hundreds of thousands or millions of documents or 10 millions of documents. And you'll pull just those relevant chunks that are most relevant for this query of the user. And then you'll construct a special prompt to give to the LLM. And you essentially ask the LLM, given this query and given these facts I just pulled out of this retrieval engine, please create a response of what it is. And then sometimes you can also validate the response to make sure there's no like discriminatory language or political language or something that you don't want to throw out, so you can kind of filter through that. But for the most part, usually you can just send the response straight through and show it to the user. And that's really what the flow is. And I, again, wanted to show this to all of you to show that there are a lot of different pieces here. And in fact, it turns out that making a mistake in a process, sometimes happens. And it's not a mistake as a developer, I would tell you, like, it's not a mistake where things break and you get an error message. But if you, for example, embed differently or do the retrieval in the wrong way, you should get wrong facts. And it's one of those garbage in, garbage out. You're going to get a better response. So you might have an impact on quality without realizing it by making it in this way. Now, I want to also mention one last thing, which is this red arrow. And sometimes people take the response and they want to do something with it. And it goes into the agent sphere a little bit too, where you want to like have somebody send an email with the response or open a Jira ticket or something like that. Now, so this is how you do it yourself. And the main, I would say, interesting thing about Vectara, one of the main things about Vectara, is that Vectara, we're a RAG as a service. So we took all of this complexity, all these pieces, and we put them sort of in a box. And so around this box, there's an API, which I'll describe in the next few slides. But generally, you take the data from where it is, and you send it through to the indexing API. And in that process, we take care of the extraction and the chunking and storing it in the vector store and everything that I just described earlier. And similarly, you can take the query, and using the query API, we'll do the embedding of the query, the matching, the retrieval, all those things, calling the LLM and giving you back the response. So all that is taken care of. So you don't have to worry about it, and you can actually scale your application up and down without worrying about this. All right. So with that, kind of again a summary of why Vectara is helpful. As I mentioned, again, building this RAG pipeline is more complex than it seems. And I wanted to highlight a couple other things that I didn't talk about in the slide. One is that good retrieval, a lot of people talk about the vector database and similarity search, but good retrieval also involves more capabilities. And two that I want to mention here that we have, one is called hybrid search, and the other one is called max marginal relevance. And I'll talk more about them in the workshop on Tuesday that Katya mentioned, that I'll do an hour deep dive on a bunch of these topics. But sometimes you want more than just very simple similarity search. Cross-linguality is a really important thing, and again, more difficult to do with other languages like Chinese or Arabic and others. There's also the idea of, in a hackathon, you put together a demo of an example, but as you want to scale this, you start having to think about, oh, who's maintaining my application? Who's making sure it's running with the right latency? And I have to have a team of MLOps or people who change the prompts all the time and things like this. And then, so it's essentially when you move from a kind of an MVP to a full application, it becomes more complicated. So those are kind of some of the reasons that are shown here. Now, I want to mention one more thing before I dive into a little bit of code to show you a couple of examples of how to use Vectara. We also created something really, really interesting last November. And you can see some of the links here. This is something called the HHEM, Hallucination Evaluation Model. And you can see here, this is showing a leaderboard of all the LLMs available, both commercial and open source, and what their hallucination rate is. And the HHEM is a model that can detect hallucinations by comparing the response generated by the LLM to the set of facts it was provided, and kind of doing that very quickly and very reliably. And so one of the use cases is, of course, to use it in your application. So for a particular case where user query, you can show them whether it was hallucinating or not. And again, I'll talk more about this in my workshop on Tuesday and show you how to use that. And then, so I encourage you to go. It's really cool, and it's integrated in our platform today. But I also want to show you that the interesting piece, we work with the community quite a bit, and with many of the vendors of the large language models today. And not all of them are the same, right? So GPT-4 is pretty strong. There's a new model from Intel that just came out. We have Cohere, Anthropic, but you can see that all the vendors are improving this over time, but it's still kind of work in progress, and there's still quite a bit of hallucination. All right. So now let me go to show you a little bit of how to build with our API. And again, I'll have a lot more of a detailed walkthrough with a lot more details about the HHEM and other stuff on Tuesday. But for time here, I only have a limited amount of time. So I'm going to show you some of the main ideas and the main techniques using the API. So generally, building RAG applications with Vectara is very easy. It's you sign into your Vectara account, and you all should already have a Vectara account. And if you don't, you can generate one really quickly. You can invite your team members to your account that you want to use, and then create a corpus. A corpus is a name we have for equivalent to an index in the database. That's where all this data is stored, your text and your vectors and everything like this inside the platform, and ingest your data in there. And I'll show you how to do that. And then you build your UI, your user-facing application that calls Vectara for querying using the API. And that's it. And really it's really that simple. You don't have to choose a vector database. We have it inside. You don't have to all these other pieces. You don't have to worry about. I encourage you also to go to this link later on. This is a quick start that has a little bit of a walkthrough of our specific capabilities, how to use the console and things like that. So let's talk about indexing. So we have a few options for indexing in the API. This is called the standard indexing API and is the one that's usually used most commonly. And the way you use it, and this is an example in Python, you create kind of what we call the Vectara document structure in JSON. So you have a document ID. This is a unique ID you specify for each document you index to it. You can have some metadata JSON, which has it's a stringified or it's a JSON string that has all the metadata at the document level. And then you can have sections, and each section is like a piece of text or portion of a document. It could be like a section in a document, which is how we kind of why we call it section. Again, this is not a chunk. This is a piece of text that could be very long if you choose to use it, and we'll chunk it internally once we process it. You can have a title. You can have the text itself. You can also add metadata, which I didn't show here for just for brevity. And then once you have this document structure, you can put in your Vectara customer ID. You can put in your corpus ID if you use multiple corpora, and this particular document. And then with the API key, you go and send it out to indexing. And once it's returned, it's indexed, it's ready to go. And when a query now comes in, it will show information from that document. And indexing takes, very quickly, usually like under a second. It's very, very fast. And then after the, and this is, if you want, this is the URL for more information from our documentation. There's also a file upload API, and the file upload API is to upload actual files. So I mentioned earlier that you can upload actual PDF files and doc files, etc. So here's all the file types that we currently support, and it's quite a bit. And again, it's a little bit of a different call. You have a different kind of endpoint here with upload. You have to specify here the customer ID and the corpus ID in a little bit of a different way. Put in your API key. And this is how you specify the file. You give it the file name, and you give it the actual binary content of the file, which kind of gets uploaded. And again, you can add some metadata. And after you do that, this gets, again, uploaded. Text is extracted automatically by the Vectara backend and chunked and indexed into your corpus. So again, nothing you have to do further than that. I want to mention about CSV and Excel files. A lot of people ask about it, so I want to kind of get ahead of this a little bit. CSV files that you can see are not supported or Excel sheets. And the reason is because they usually look like a table and just indexing, and usually there's a lot of numbers there. And so it's not obvious how you might want to index a CSV file. Usually what people want to do is to take some of the columns that are textual and index like one row at a time to be almost like a document, a document like this. So make one section from one row of the CSV file. And so usually you would want to process it outside before in your client indexing sort of code, and use the standard indexing to create a structure like this. And I have a link here for a blog post I wrote that shows that in more detail if that's your use case. But if you try to upload CSV directly, it will work. So just or Excel sheets. But anyway, that's the file upload API. You can again see more stuff in the documentation as well here. All right. I also want to mention a couple other ways to ingest data. Um, there is a upload file drag and drop mechanism in the console. So that's, again, not a scalable thing for many documents, but if you have just a couple and you want to experiment really quickly, you can go to our console in your account, just drag and drop a couple of files. And what happens is it then uses the file upload API behind the scenes for you. So it's um, but you can't add some metadata. It's a little more limiting, but I advise to use the file upload API. But that's one way. There's also a open source project that we created called Vectara Ingest. This is something that you can utilize and to ingest. It has a bunch of different crawlers. For example, a web crawler, a kind of a folder crawler for PDFs, all kinds of other crawlers like for Wikipedia, for Slack, a bunch of different source information. Continues to be developed, and thanks also for the help from our community for keeping us up to date on that. Again, so if you're interested in looking at that, it's actually really easy to use and has a lot of indexing and crawling of sources kind of baked in. It also recently has this advanced feature of summarizing table content for table processing. Again, just a plug for next Tuesday. I'll have a workshop and I'll talk about this advanced type of processing there in more detail. Our partner in this hackathon, Unstructured.io, also is a good something to look at. They have an ingestion pipeline, and we have a blog post you can look at later that shows how to ingest with them. And also, I want to mention two other of our partners, Airbyte and Datavola, who also have integration with Vectara to ingest data into the platform. All right, so that's ingestion. Now let's look at querying. So once you have the data in, you can query using this API call. So you give it the query string, you give it the number of results you want, and a couple of things to note here. Corpus key is a kind of an array of, you can have more than one corpora. Usually people have just one, but you can have more if you like. And then this is, and again, I'll explain this more on Tuesday. This is something called a hybrid search, which allows you to combine neural search and kind of traditional keyword search. So if you set up this lambda to a value between 0 and 1, 0 is pure neural search, and 1 is only keyword kind of type, kind of old school search. And so you can actually do a hybrid and get them to be kind of something in the middle. So if you see that lambda value, that's what this means. You can also choose different prompts. And this prompt particularly is one of our prompts, but I'll show you later on. There's a couple different prompts you can use, and it's in our documentation. And then once you have this query body with all the specification of what you want, you can just call it like this. This example is in JavaScript in this case, I think. So two other things to note. This is something people don't always understand, and I want to highlight what this is. The sentence before and sentence after. So outside of the facts that get retrieved, you also have this ability to add a few sentences from the same document before the matching part of the chunk, and a few sentences after the matching part of the chunk. And sometimes changing those numbers gives the LLM more context, and it's really useful to use that and try that as well. So that's how you query. And Katya mentioned chat, and I want to point out that our chat functionality right now is really cool. It's something we launched a few months ago, and essentially, in order to do chat, you don't have to now worry about memory of the chat history or anything like this. It's all done through our platform. In the query body, you can add a new segment called chat. And if you say store equals true, it stores all the chat history. And the first time you call it, you put conversation ID as null. And then in the response, you'll get a conversation ID that's assigned to your to this chat session. And then if you include that in the conversation ID for the subsequent calls in the same sort of user session or user chat, it will consider the history automatically in your chat and give you a relevant responses. So we'll see an example of that as well. And then, okay, so in addition to just using the API, there's a lot of tools we've built over the next few months, the last few months, sorry, to help you build user experiences much faster. Again, very useful for a hackathon. So Vectara Answer is one of them. This helps you build a question answering user interface, and we'll see a couple of demos of that in a minute. Again, very easy to build within literally an hour. You can build a fully functional question answering minutes. I do it in minutes, but maybe it'll take you some time to read how to do it, read the README. There's also Create UI, which is a JavaScript tool. All of these, by the way, are open source. So you can also look at their code, but you can also use them. It allows you to build a sample code base locally for your application that could be either chat or just search or question answering, like similar to Vectara Answer. We also have React components. For those of you who write in React, there's a chatbot component and a search component, and a similar set of capabilities for JavaScript only for people who don't use React. And then there's also some examples on Hugging Face of how to use the chatbot with Python. So again, the code there is publicly available, so you can take a look at that as a reference. Okay, so those are some of the tools. I just wanted to give a big shout out to a new community effort led by Tonic, who I think is also participating in this hackathon. He created this tool called Vectara CLI. It's in beta version, but if you're interested, I encourage you to take a look at it. It's available on PyPy. And by the way, just to mention, we have one of our partners in this hackathon is Tonic AI, which we'll have you'll learn more about later today from them. But it's only coincidental that Tonic's Discord handle is Tonic. It's unrelated to the company. Just a coincidence. And then I wanted to show you some of the UIs that I mentioned earlier. So this is an example of, I'm going to click on this to go there. This is an example of a Vectara Answer built application. You build the application, you can specify, you can add this or remove this, you can specify all these text options, etc. This is an example of stuff that we crawl different news sources to get up-to-date information, and then we can ask questions about the news. So for example, if you ask this question, you can see that it goes and retrieves the information, gives you the response, and also gives you the citations, right? So you can click on number 4, as I mentioned earlier, and it gives you like a lot of confidence to the user because they can actually go and look exactly what the matching part was and a little bit of before and after, and can click on this to go to that page as well. So that is an example of this type of, oops, here. I mentioned React chatbot. I picked that one because I don't have enough time for all of them. But again, just so you can see, it's very easy to use. If you're a React developer, you just install the React chatbot, you import it, and you can actually just add your div here with different parameters. And then you just have a chatbot integrated into your React app. It's that simple. Customize it and go. And as I said, there's some Python-based examples of chat also on Hugging Face. So this one was built with Streamlit and Python on Hugging Face. I can show you that one too. We here crawled a bunch of information from the IRS website. And by the way, just a full disclosure, don't use this to file your tax returns. This is just for demo purposes, and ask your tax advisor. But again, you can ask questions like, can I or let's say, is my mortgage tax deductible or something like that. So it's again, it's a chatbot interface, and feel free to, I'll wait until it finishes. But you can see that the files here are, open. You can look at these two files to see how it's done. And that is it. I wanted to mention three important things. One is, as a special bonus for this hackathon, I'm going to enable all participants who have an account for this hackathon access to our what we call the scale features. This means that you can use a GPT-4 Turbo in your prompts, which gives you higher quality within Vectara, and custom prompts. Again, more of how to use custom prompts in my Tuesday workshop. And again, the free platform allows you to do only GPT 3.5 Turbo. And so we're enabling, if you want to use within your Vectara environment, the prompts that are taking advantage of GPT-4 Turbo, you'll be able to do that. And again, if you're interested in that, please come by to watch my workshop on Tuesday. And as Katya said, we have a CJ from our Vectara UI team. He's going to present a really interesting talk about using the UI tools and how to build great UI for RAG on Monday. And I will do the advanced RAG workshop with a lot of really interesting topics about advanced RAG on Tuesday. And then I also have some more resources for you here, our documentation, the Vectara Discord, again, not to be confused with the LabLab Discord. And then our GitHub, which has a lot of the open source code I mentioned. We also have some example notebooks that show you how to, so ready code that you can use to look up if you want to looking for reference implementations. And then we also have a startup program, so encourage you to look at that if you're a startup participating in this hackathon and want to follow up after the hackathon to look at our startup program, which has some good benefits for startups. And with that, I want to thank you all for listening, and we'll let me stop sharing here. And I think now we'll move to Katya to get us to the next speaker.
Yep, that's true. So thank you very much, Offer, for presentation. I'm inviting the next partner, and we have Adam today from Tonic AI. Hey, Adam, can you hear us?
I sure can. Are you able to hear me?
Yes, we can.
Excellent.
So awesome, Adam. Please, yeah, say some words, and I will just be in the background. Thank you.
Okay, I will. I'll certainly say more than a few words. Ofer, thank you for the kind words about Tonic AI. I'm very excited to be have our companies partnering together on this hackathon. I hope all of the participants create some very cool projects. To get us started, I will quickly share my screen. I'll do that now. Excellent. Is everyone able to see a Google slide presentation? Excellent. Okay. So I'll put it. I'm not going to put it in slideshow mode. I only have 3 slides. I'm going to keep this quick, and then I'm going to hop into the product because I think that's a lot more interesting for everybody. So, what is Tonic Validate? Well, Tonic Validate is a product created by Tonic AI. For those that are on their computers right now, check us out, Tonic AI. We are a development tools company. We build development tools for software engineers, for testers, and also for data scientists. And one of the tools that we develop is called Tonic Validate. Tonic Validate is a RAG evaluation framework that helps you monitor the performance and quality of your LLM-based applications. Primarily, though, it's used for RAG systems. How does it work? Well, there's two components to Tonic Validate, and I'm going to go over both of them in a few minutes. The first is a free and open source SDK. It's open source, it's MIT licensed, you can use it however you like. This SDK, available on GitHub, and I'm going to go to that GitHub momentarily, does all of the number crunching around kind of answering the question, how good is the answer that my RAG system is providing to me? How good is the retrieval? Like, how happy am I with these answers? That's what the open source SDK aims to achieve. And then on top of the open source SDK is a UI that we've built for you that allows you to monitor and track your RAG performance in real time and as you develop your software. So let's see how all of it works. Here's the open source repository. It's available here, Tonic AI / Tonic_validate. In fact, I'm gonna quickly go to the Hackathon channel, and I'm gonna drop that link into the Hackathon chat right now, just so we all have it. So go check it out. Give us a star if you like it. You know, we'd love to see that. So let me show you how this works. You install this via pip. It's a Python SDK. And then what you'll do is you'll go down here and you just need to add this small snippet of code to an existing Python application where you're working with your RAG system. I'll give you a very quick walkthrough of how this works. For a moment, let's actually ignore the text that I've highlighted. Let's start right here with the benchmark. First, you create a benchmark. A benchmark is just a set of questions that you want to test your RAG system against. And then you can optionally provide a set of reference answers. These would be answers that a human has determined are good answers to the accompanying question. And you can provide as many questions and optional answers as you like within a benchmark. You then create a validate score object, and then you run the score method. And what the score method is going to do is it's going to score the questions in your benchmark. It's going to evaluate the question and then the answer provided by the RAG system, as well as the context the RAG system has retrieved. And it's going to compute multiple metrics that are kind of showing you how the answer performs across a variety of dimensions. Oh, of course. Thank you for whoever did interrupt. That's helpful. I want to make sure everyone can see this. Let me zoom in just a little. How does that look? This is better. Wonderful. Thank you for calling that out. So you call this score method on your benchmark, and then the only other item that you must pass into this score method is a callback into your RAG application. And that callback we define right here. This is that function I said ignore for a moment. In this callback, above this return statement, you would simply call into your RAG system. You would retrieve the answer from the RAG system as well as the context, and then you would pass it into this dictionary that you'll return. So essentially, call your RAG system, get an answer, get the context, throw it into a dictionary that looks like this with an LLM answer key and an LLM contextless key, and then the score function can evaluate your answer to determine its quality. So I'm talking about quality and metrics. Well, what do I mean? So Tonic Validate can analyze your RAG system across a variety of dimensions. These are some of our more popular metrics, but actually if you go into the metrics folder in the code, you'll see that we have over 20 metrics that we support today. Here's a few of our popular ones though. The first is answer similarity score. This will take the RAG generated answer, a human reference answer, and compare the two to determine how comparable is the RAG answer to the human generated answer. A higher score means the RAG system had a closer match to the reference answer. So a higher score is better, in fact, for all of these metrics. Another good metric is retrieval precision. This measures whether the context retrieved is relevant to the answer. So how much of the answer is kind of like contained within the context that was retrieved? This is a good way to kind of analyze how well your RAG system is retrieving context. Recall that there's really multiple steps in a RAG system. One is the context retrieval, and then another is an actual answering of the question based on that context retrieved. Answer similarity score is kind of doing an end-to-end test, whereas retrieval precision is focusing primarily on the actual context retrieval itself. And then we have many other metrics as well. Many of these metrics actually require the use of a large language model for the computation of the metric and of the score, but many of our metrics do not require large language models for evaluation. For example, we have a latency metric, which will tell you how quickly your RAG system is providing you with an answer. That does not require a large language model, of course. So we do all of this. This is available in an open source SDK. Anyone can go use it today. When you run your score method, you're going to get a run object back, which is essentially a data frame of your questions and their scores. And with this data frame, you can do what you like. Many of our users, though, find a lot of value in our UI as well. So let me show you how that works. I've already logged into my account. Here I am at validate.tonic.ai. You can create your account. If you go to tonic.ai/validate, you'll have a link there to create an account. And in fact, let me go back into the chat, and I will quickly provide a link to this, tonic.ai/validate. So go there, and you can create your account. So I've already created a few projects, but I'll show you quickly what a project looks like when you first create it. We need to install the Tonic Validate SDK. And then here, this code snippet is exactly what I just showed you in GitHub. Additionally, though, there's two more lines. Here, I am going to create a validate API object. I'm going to initialize it with my API key. And then I'm going to begin uploading runs. You know, the runs that I upload are essentially the metrics that we computed when we ran the score method. And then as soon as I run these two additional lines of code, it'll start populating the UI with my metric. And I've already done a few projects, so let's look at some of those. Here's a project where I created a RAG system that used as its knowledge base a set of essays written by Paul Graham, who's a startup guru and one of the founders of Y Combinator. And we asked the RAG system questions about, you know, various pieces of information and trivia found within Paul Graham's essays. So I started doing runs approximately a month ago, and I've been doing them, you know, up until April 8th. And I can see over time that the overall score of my RAG system has been improving. But this overall score is kind of like an average score across all questions and all metrics. So it gives you a good insight into the overall trend, but it doesn't help you really dig into, well, what questions are performing well and which are performing poorly. Because it's easy for an overall trend to go up, but individual questions to actually perform poorly. So let's dig in a little more. Let's, for example, focus on retrieval precision. Here I can see also, we kind of have like a sawtooth looking waveform, but it is trending upward. But if I go down to this question list, I actually see, yeah, most of my questions are in fact trending up. That's great. But I have one question that's trending down. So if I click on just that question, I can see that in fact, the retrieval precision for this specific question has been decreasing over time. So either somehow, so something is going on with retrieval. It could mean that maybe my knowledge base has changed and that's causing confusion. It could be that I've changed my chunking or vectorization or vector similarity search strategy, and it is somehow negatively impacting the retrieval for this question. But now that I know this, I'm able to dig into the issue further. Additionally, in addition to all of this high-level UI, I can go look at individual runs that have been uploaded in the past. For many of these runs, I've added tags when I uploaded them that help me kind of understand what these runs were. So all of these runs are, you know, tagged prompt v3. Earlier, I was on prompt v2. This is all nice to know. Looking into an individual run, I can see the scores for each question that was uploaded. I can also see additional metadata that I sent in my SDK upload call as well. So I know that for this run, I was using this version of the LLM. I was using this as my parameter sweep, and my system prompt was you know, something related to this GUID, which is, you know, in an internal system of ours. So this allows you to continue kind of tracking the progress of things over time. The last thing I'll show quickly is another project where actually I didn't make any uploads here. I connected the Tonic Validate SDK into a GitHub action, which every time I check anything into my master or main branch, I'm going to do an evaluation and upload it to the server, and this all happens automatically via GitHub Actions CI/CD pipeline. When you perform it in this way, and this GitHub action is available in the GitHub Marketplace, by the way, you have the ability also to click on individual points, and then you get information related to the GitHub commit that actually caused, you know, the change in overall score. So here, if I went on to this Git commit, I would see, okay, this is a pretty big drop in overall score. What's going on? I could figure it out. Clearly someone did, and then we were kind of back on track with the next commit. So that's good. Okay, so hopefully this is interesting to everyone. The evaluation and performance monitoring of RAG system is obviously crucial to any RAG system being put into production and being used by users. But specifically for the purposes of this hackathon, I want everyone to know a few things. Of course, there are prizes. We are offering $500 in cash for the best solution that makes use of Tonic Validate. Make sure to include screenshots of your project visualizations in your submission. So if you create a RAG application during this hackathon, connect it to Tonic Validate, send us some visualizations, and you could win $500 in cash. During the course of the hackathon, it's typically common that folks have questions or that they hit issues where they need assistance. If that happens to you, there's a few ways you can reach out. You can file an issue on the GitHub SDK, which I've already linked in the chat. You can email us directly at validate@tonic.ai. Or if you're in Discord, you can ask questions and tag me at Adam@Tonic. So that's it for Tonic Validate today. I hope everyone enjoyed that, and good luck in the hackathon.
Thank you very much, Adam. And I'm just quickly stepping in. Wait for everyone coming in. Okay, we have Jerry. Jerry is here, and we are going to the next speaker. Hi, Jerry.
Hey, thanks for having me. It's great to be here.
Hi, Jerry. Jerry is going to represent LlamaIndex today. Jerry is a co-founder and the CEO, and I am passing the mic for you. Please say whatever you want to say, whatever you want to share for this hackathon. Some useful tips, some useful things, yeah. And yeah, I'm passing mic to you. Thanks.
Sweet, sounds good. Thank you. And let me just share my screen really quick. I'll just walk through a few slides. Right. Cool. So I think I have like 13 minutes or so. And so, the goal of this really is to, just go through some basic concepts of advanced RAG, highlight some offerings within the LlamaIndex ecosystem, show how you can use LlamaIndex with Vectara actually to, build different types of RAG solutions, and then talk a little bit about some interesting concepts that could be useful, whether for this hackathon or beyond. So for those of you who aren't familiar, LlamaIndex is a framework for LLM application development, especially over your data. And so that's basically where the whole concept of RAG comes from, which is, you have unstructured data, you have semi-structured data, you have structured data, and you want to use that with the language model of your choice. So we provide an overall framework to basically orchestrate all these different types of use cases: RAG for question answering, structured data extraction, conversations, agents, and more, over all the different modules that you might want to use, from LLMs to data to embeddings to vector stores and more. The overall ecosystem of the LlamaIndex open source project includes both a Python framework. This includes a TypeScript framework. It includes Llama Hub, which is our hub of integrations, from data loaders to tools to packs, which are templates, as well as data sets, and also full stack application templates. So I'll go through just a small subset of these, and some of these are actually pretty useful for a hackathon setting, because you basically are able to get up and running very quickly with an initial scaffold of an application, without really having to do much work, which is a good way for you to get started to go write your own thing. So the first example that I'll show, which I think actually ends up being pretty popular during hackathons, is Create Llama. And so for those of you who are familiar with Create React App, Create Llama is our tool for basically just generating a full stack LLM application. And so you basically get back like a chat interface like this right here. So if we see like a hackathon project with interesting color gradient in the background, you likely will have used Create Llama, and that's totally fine. It's a good way to get started. You are able to pick from a variety of different options, different LLMs to choose from. And you'll just be able to go through like a CLI menu type thing, where you select like the backend you want to use, a bunch of other configuration options, and you're able to just get back a full stack thing that works. And then of course, you can and should customize it for your needs. Another example, which came out last year but is still relevant, is SEC Insights, which is like a financial analyst app that we basically built ourselves last year and open sourced the entire template. And so we launched this as a way to basically, build an interesting advanced RAG application with a PDF viewer with citations in the loop. And this is very easy for you to clone and basically just substitute your own data sources and leverage some of the core components within the app. There are some other components as well: Chat LlamaIndex, Llama Packs, which are overall templates for you to get started. These are a bit lighter touch than some of the full stack repos. And these mostly represent like little code templates that you can use to build different types of applications. And we have like a dozen plus advanced RAG templates for you to get started. And the last bit, which is related to the second part of this talk, is if you're interested in building agents, we have a lot of agent abstractions within LlamaIndex with a lot of implementations. Some of the most popular ones are just React as well as function calling. And you can plug in different tools to help you get started building these types of agents. One sec. Okay. And we have a Slackbot project as well. So I'll link the slides. I know I'm going through them relatively quickly, but I'll link the slides in the channel as well so that you're able to take a look. Most of these have links for you to get started. And specifically, there is some nice resources put together by Ofer from Vectara, as well as from some of our own founding engineers. And there's basically two ways that you can use LlamaIndex with Vectara. First is you can use Vectara as a managed index. And what this means is that Vectara will actually handle the data ingestion and indexing, and then it will expose like a retriever or just a full end-to-end RAG pipeline that you can use. And assuming you leverage the retriever capabilities, then you're able to plug that into the rest of LlamaIndex abstractions. For instance, you could compose like more interesting retrieval systems using that retriever. You can compose an overall agent on top of the Vectara like query engine. And you can add in other tools like web search, calendar, Gmail, all that stuff, in addition to a RAG pipeline. So this notebook should give you a good way to get started just using LlamaIndex with Vectara. And we have a pretty good integration by default there. The next piece is, I think, Ofer actually put together a really nice notebook with Llama Parse and Vectara. And so Llama Parse is actually part of our enterprise offerings, but we have free credits for everyone to get started. And it's our proprietary document parsing solution that's very good at table extraction and parsing out embedded objects. And we have a nice notebook showing how you can actually use, if you have very complex PDFs with a lot of tables, you can use Llama Parse as a pre-processing step to actually parse out this document into either Markdown or JSON and parse out the tables and images, and then extract out all that data and then put it into Vectara. So this will override some of the default ingestion that Vectara provides, but you're able to use it as a storage and retrieval system. And so I think in the last few minutes, I'll probably just quickly talk about the overall Llama Parse offering that we have, because it complements the LlamaIndex open source toolkit pretty well. And so specifically, if you're interested in building advanced RAG, you might be interested in building RAG over very complex documents or data sets. So one of the key questions we asked very early on is, how do you actually model complex documents with embedded tables and charts? This is just an example of a simple Wikipedia article, right, about like the world's billionaires. But just in general, if you think about financial reports, insurance documents, or construction, architecture, diagrams, like all these things, there's usually some fancy either pictures or tables or charts within these documents that ideally you're actually able to have the LLM understand and reason over this data, especially for RAG. And so what we found is that naive solutions, if you just plug this into the most baseline possible RAG pipeline setup, you will probably end up getting failures and hallucinations over this data. And so what you actually need, right, is a few different components. You need good parsing as a baseline, as a necessary component. So you need good document parsing, and then you need good indexing and retrieval algorithms to actually parse out these complex documents beyond just like existing kind of like more naive RAG setups. So what we really wanted to do with Llama Parse is solve that parsing components. And just a very classic example is if you take PyPDF, right, which is very basic open source PDF parser, there's and you throw in some sort of like unstructured documents like with tables and all these things, then this is the AXA like financial reports. there's a good chance that your open source PDF parser is going to just mess up a lot of the formatting with the text and the numbers. And the issue is that when you actually do that, it does lead to hallucinations because you end up kind of messing up the spatial positioning of the text and numbers, and it ends up being harder for the LLM to reason over. So Llama Parse is just a special document parser designed to let you build RAG over complex documents. And so we have some links here on how to get started. Anybody can basically sign up for an account. We have some free credits per day that you're able to use. It's like 1,000 pages. And if you need more, feel free to ping the channel as well. And it has a few key properties. It's pretty good at extracting tables and charts. It has image extraction capabilities. It supports 10 plus different document types and allows you to input natural language parsing instructions. So you're actually able to prompt the service to extract out text in the way that you want it. There's some setup instructions in the slides, which will also link, and just a showcase of some of these capabilities. You take a very baseline approach of, asking what is the repayments of debt and the cash flows from financing activities for Netflix, and you have the Netflix like 10K document. And if you take just a naive RAG setup with PyPDF, you end up not being able to find the answer. Right? But if you follow some of the notebooks in the repo and basically are able to leverage Llama Parse along with some like advanced RAG capabilities, then you're actually able to get back the right answer right here, like 500K December 2021. There's some more results here for your viewing pleasure. The other part here is that you're actually able to output parsing instructions. Or input parsing instructions. So, in contrast to maybe like PyPDF or existing parsing solutions, you're actually able to like prompt this a little bit. So Llama Parse is powered by GenAI models under the hood. And if you say something like, given this piece of text, which is like a calculus snippet, you can say like output any math equation in LaTeX Markdown. Then this, it actually will follow your instructions, will output equations in LaTeX Markdown. And then this is actually the result of the LaTeX render. So you can basically prompt the extraction to output things in a certain format to help your RAG setup. There's also JSON mode, which by default, we extract stuff into Markdown or text or just like plain text. If you want a more structured approach to actually, you want control over parsing out the different items in the documents and apply your own algorithms over it, then you should leverage JSON mode. And then you're able to parse out both images as well as text blocks. A few of these other examples go over things like RAG over PowerPoints. And there's also some other examples in this overall repo. So if I just go here, you're able to see this notebook. Okay, I think I'm basically out of time. There's an entire section on how to build agentic RAG, which I didn't have a chance to go over. But this is just some interesting conceptual things about how do you take like basic RAG systems and make them more advanced. And here's a bunch of slides going from simple to advanced forms of agent reasoning. And what this allows you to do is you're able to build kind of more complex question answering systems that can not only answer like simple questions, but actually reason over more complex questions as well. So I'll, again, link these slides. Apologize for not being able to go over it. And then I think, correct me if I'm wrong, the prize is $1,000 for the best use of LlamaIndex / Llama Parse. And so that is what we're offering in this hackathon. And I think with that, my time is up. And so thank you all.
Thank you, Jerry, for presentation. Well, unfortunately, yeah, like we have a new speaker coming in. However, we will keep your useful slides, and if there would be some questions, we can link them. I think like for public use, just to have a look by participants, right? Also, there was one question about KGS in the chat, I mentioned that this question would be answered during Q&A, but Jerry, if you have a short answer, you can just share it now.
Sorry, could you read out the question? I'm trying to find the chat.
Sure. Sure. So the question was just like, how about using KGS? So that
Oh, I
was
see.
referring to, yeah, to you.
Yeah, we have a bunch of like tutorials for how to use knowledge graphs. This is maybe a little bit separate from the existing resources I pointed out, but we have resources for how to use set constructed knowledge graph with LLMs and then also query it in like 7 different ways. But if you're interested in that, feel free to check out our documentation and basically just like, there's a search bar and you can search for knowledge graph tutorials.
Okay, perfect. Perfect. That's a pretty sweet and short answer. Thank you.
Right?
I'm welcoming in Chris. Chris is representing Unstructured. Chris, head of product marketing. So, hi, Chris. Can you hear me?
Yeah, I can hear you. You got me?
Uh, yeah, we can hear you. We cannot see you yet, but I think it's just about to change. So I'm gladly passing mic to you. Yeah, please go ahead, share a few words from the unstructured side about this hackathon, and we will just be in the background.
Thank you. Hey all, I'm Chris Maddock. I lead product marketing and solutions architecture at Unstructured. Unstructured is about 18 months old now. We've done about 7 million downloads of our open source package. We've got about 45,000 organizations using our company, and we've just announced a Series B fundraise. We are looking for developers. Please shout. All we do at Unstructured is focus on transforming unstructured data and preparing it for retrieval augmented generation or fine-tuning tasks. We work with 30 now plus file types. There's 30 plus connectors to your systems. This is the only problem that we solve. PDF files, PowerPoint files, all the types that you hear from other providers, plus along with emails, HTML. The list is a mile long and it's also fully multimodal as well. We work with a stack of document layouts. Early days of me being a software engineer, I still remember working for the British government and getting the chance to ingest a load of CSV files and thinking, I'm not paying £50 for a CSV parser. I'm just going to write my own. Then, found some extra commas in there, found some escape characters, found some special characters, worried about file encoding, decided it was better to pay the £50. Now, imagine that problem applied at the scale of heterogeneous documents. Imagine when you're thinking about all of the different file types in the world, all of the different layouts. That's where we come in. We're focused exclusively on all of those file types, all of those layouts, all of those connectors. Our table of form extraction is up there with the absolute best in the market. We rate this constantly and compare it daily and iterate on its performance. We worry about reading order, left to right, top to bottom, column based. Everything we do is broken down to this concept of semantically coherent elements. You can see here, this page is broken up. So you'll see when you get our document transformed into its JSON structure, this is a title, this is a subheading, this is paragraph text, this is an image, this is a table, and that reading order is maintained in the output JSON schema as well. Everything is wrapped in metadata as well. There's 30 plus pieces of metadata that come through right now. All of that is passed along with your converted JSON. So you get your source file, irrespective of what its type is, converted into this standardized canonical JSON schema, all broken down by element. You know what the heading is, you know what the paragraph text is, you know where the tables live, and it's all wrapped in this metadata. Where did it come from? What's the file name? What people are using it? What's the subject of the document? Was it an email? Who was it sent to? Who is it sent from? So this whole thing is packaged up. This is it if you look at it from a top-down architecture perspective. Bunch of connectors on the right. They're just a sample of them. There's way more. Bunch of data formats next. There's, again, just a sample of them. I just couldn't fit any more on this slide. They're connected to and they're brought in. And there's 3 different strategies for how we address this data: fast, high res, and next gen. Think of this essentially like fast is heuristics, regular expressions, whatever it takes. High-res moves in traditional NLP models, and the next-gen models are where we'll deploy LLMs and vision models to get at your data. Transform that into the JSON schema, put it in a cache, because we're still not sure what embedding models, what retrieval strategies, what vector stores work best for each use case yet. Put it through our own chunking algorithm, pass out to an embedding provider, and write that into a vector database and keep it permanently synchronized. Everything's kept in order. The idea of how we work is based essentially around these three concepts, the fast, high res, and the next gen. If we can get the answers out of your file with just regex and heuristics, we will do that. It's the fastest way, it's the cheapest way. If we have to go to traditional NLP models, OCR, we will do that. If we have to go to an LLM to help, we will do that. But everything we do is about eating our vegetables, grounding that work in the most cost-effective, fastest way to get your data, only scaling up to the bigger models if we need them, because we're inherently concerned about the total cost of ownership of these stacks. There's three ways to interact with our solution right now. There's our open source solution. Just pop along there and hit pip install unstructured. There's a free API, which is shared in our documentation. Just hit unstructured.io and you can link to it from there. There's a commercial API and there's a commercial platform that's launching next month, which is no code effort. Here's the link so you can just like quickly dive into that free API if you just want to use that QR code to get there. But our idea is simple, like good data equals good AI. Our entire company, all 35 of us, are only focused on document transform. We're growing and we're operating at the left of the vector database, ensuring that we're getting good data into that vector database so your retrieval solutions, the other side of it, are working on the best available content. And that is me. Thank you all for listening. We are also in the prize game. There's $1,000 for the best use of unstructured. The free API is available for you to use. We also have a community Slack forum. If you look for unstructured, you'll find that on the web, community Slack. Join that, and we have our engineering team standing by to help you with any questions that you have there. That's me. Thank you very much.
Thank you, Chris. Let me just quickly check what also check about our next speaker. This is the last one from Together AI. So let me just make sure that Hassan is around, and then we can move on to the last speaking person. Okie dokie, Hassan is here. Yes. Okay. So Chris, thanks for your presentation. Now we have Hassan. He just arrived, and yeah, we can pass the mic to him. Hi, Hassan. How are you doing?
Hey, I'm doing great. How are you, Katya?
Good, good. Thank you for coming today. We are actually closing this opening with your speech. There have been so many useful presentations already. So once you present, there might be some questions, but please go ahead. I'm passing the mic to you.
Sounds good. Thank you. All right. I actually don't have a presentation, but I will go through a couple things and we'll go through some code together. So this will be a little bit hands-on, and I'm just here to tell you a little bit about Together AI. So I'll just kick it off. Hello, everybody. Welcome. My name is Hassan. I work on developer relations at Together AI. And at Together AI, we're the fastest cloud platform for building and running generative AI. And we have 4 main products. The first 2 are probably going to be the most useful to this audience, but I'll go through them really quickly. One is we have Together Inference, and we essentially let you run inference on a ton of open source models. So chat models, language models, code models, image models like Stable Diffusion, all of that stuff. So we just give you an API and you can just call any of these models and get a response back. The other thing we have is fine tuning. So we let you fine tune a select group of open source models by providing your own data. And those kind of run on our GPUs, and then we host the models for you, and you can also download them later. And it's pretty great. The last two we have are GPU clusters. To teams that kind of just need GPUs and want to train models or run inference or do whatever they want, and they have their own stack, and they have everything. We offer GPU clusters. We have a training stack as well, where we help people be very hyper efficient with our GPUs. And the last one is kind of like our consulting arm. We will work with you to build a custom model on a case-by-case basis. If you need our in-house expertise, we have a lot of kind of very talented researchers and engineers. I heard a Discord sound. Okay, everything's good. Okay, and this is the Twitch stream. All right, so that's Together AI in a nutshell. I'll dig into some code. Or actually, I'll dig into our playground first, and then I'll jump into some code. So this is our playground. This is what you get when you just go to together.ai. You sign up. You get here, you get $25 of free credits automatically, and you land on this chat playground, and you can kind of choose between a lot of open source models. And we can go to like DBRX, which actually this is the new Databricks model. I think 132 billion parameters. And you can ask it, what are fun things to do in New York? You can kind of ask it whatever you want and play around with all these APIs and get an actual response. And you can tweak all these parameters that we provide as well on the side. You can specify a system prompt. You can kind of do what you want. And for these playgrounds, if you hit this drop down over here, you can actually toggle between a bunch of different types of playgrounds. We can go to a code playground and actually use any of these code llama models. We also have like chat tuned code llama model. So if I go back to chat and we want a code model that we want to chat with, we can just look up code. And so we have like DeepSeek LLM chat and ask it like, write a Next.js hero section with Tailwind. Next.js hero section that describes a headphone product with Tailwind, because I love Tailwind CSS. And then it'll just go and write it, and you can copy the code. And so it's kind of nice that you can interact with things in this way. So this is our playground. Well, like I said, we have things for everything. Like here, cat floating in space, and you can choose what model you want. We offer a bunch of different ones, but in this case, I'm just using SDXL, and we return. You specify how many results you want. In this case, we specify 4, width and height of the images you want, how many steps you want it to go, and it will, hopefully generate some and show them to people. So there we go. Cool. So that's a little taste of our platform for the inference side. Let's actually just dig into some code. So if we go to our documentation, and we want to, so I'm going to be using our Python library specifically. You can use it in whatever language you want. We have a REST API as well. We want to query a chat model. So I'll just copy paste this code snippet over here. I'll go to my editor and I'll copy paste it in here. And so you can see this actually uses our new Python SDK. All you have to do is import together. You have to specify your together API key. In that case, I actually went to my terminal and did export together API key equals, my actual API key enter, and that's how, this gets it from my environment. And all you have to do is client.chat.completions.create. You specify the model that you want. In this case, we're querying Mixtral. You specify, what you want it to return. You can also add a system message here. This is the, the popular, messages format from OpenAI. And then you ask it whatever you want. Tell me about New York in this case. If we want to stream, all we have to do is specify stream equals true, and we can kind of loop through the chunks and print it to our terminal. So if we actually go ahead and run this code over here, we'll do Python 3 inference.py. This will query our API and it returns a result. And it's really that easy. Sign up to Together, you put in your Together API key, 4 lines of code, and you can query, 100 plus models that we offer. And you can actually view all the models that we offer if you go to inference models here. And you can see with our chat models, we have a lot over here. We have the some code models over here. We have Gemma from Google, we have Vicuna, we have Llama 2, we have a lot of different types of fine-tuned mixtrals. We have the new Quen models, DBRX, like we showed. And yeah, you can kind of choose whatever model you want here and put it in here and get a result back. Those are chat models. We have language models as well. These are kind of the base models. We have the new Mixtral as well in here, and yeah, code models and image models. Like I said, specify some code with an API, get stuff back. We also let you run fine tuning jobs. So if you have a piece of data, like a training file, and it's in JSON-L, you can simply upload it and create a fine tuning job very, very easily. And we let you specify a bunch of different parameters. There's actually more than this, but mainly like the number of epochs, the batch size, and then if you have a weights and biases API key as well. You can specify that. It'll create a fine tuning job too. You can go to our fine tuning docs as well to learn more, or to even get access to like Jupyter notebooks and stuff like that for this. And then it'll actually show up if we go back to our dashboard and we click jobs. You see I actually have a fine tuning job still running right now that I just started 15 minutes ago. And then if you go to models, it'll actually show up here. So this happened yesterday, actually. I fine-tuned a Mistral 7B model. And what's cool is that we can also run it through together and run inference on it, and go over here and do things. So that is essentially it. That's my spiel. It was pretty quick, but I just wanted to give you a taste of what you could do with Together AI. You can run inference on all these open source models. You can run embeddings. You can fine tune your own jobs and host them through Together. And it's fairly affordable as well. If we, for running fine tuned models, it's $1.40 per hour, because this is like, kind of, we're running this on a separate GPU. But for our serverless models, it's actually very, very, very affordable. So we can actually go to our pricing page real quick. We can see we charge per 1 million tokens. So, from 10 cents to 90 cents per 1 million tokens, which is a lot of API calls. And for the purposes of this hackathon, you probably don't have to worry about this at all. You get $25 of free credits when you sign up. And we also have a form to get credits for the hackathon. I think you get $100 of free credits for the hackathon, which will take you a long way. So if you go to together.ai/hackathon, you'll get this form, you fill it out, you get your Together AI credits. It's great. We recommend using our partners as well. The presentations were amazing. Like, everybody, unstructured, LlamaIndex to kind of parse your documents and run RAG, Vectara as a vector database and for embeddings. I think they all mesh very nicely with our inference stack and with our fine tuning stack. You can do, I know this is a RAG hackathon, but you can fine tune a model on Together and run RAG on it. And you can kind of just do a lot of cool things. So we'll be available throughout the hackathon. We'll be in Discord. My Twitter, or X personally, is Nutlope, @Nutlope, NUTLOPE. If you have any questions, feel free to DM me. I'm more than happy to help. And that is it. Happy hacking.
Thank you very much, Hassan, for that warm introduction. That's it. Basically, we're done. We have heard all of our partners' opening words. And I think that was very exciting opening for Advanced Track Hackathon. We have all the technologies explained. We have a bunch of useful slides and use cases. So I'm inviting everyone who was present during this opening on the Discord, where you will find Q&A session. And there you can engage with the mentors and find the answers to your questions about building or whatever issues you might experience during the hackathon. So thank you very much for staying with us today. Thank you, all speakers, and have a nice time creating new apps during this hack. See ya.
Thank you. Thank you, everyone.